On March 11, 2011, a massive earthquake struck off the coast of Japan. It triggered a devastating tsunami that slammed into the Fukushima Daiichi nuclear power plant. Critical cooling systems failed, leading to meltdowns in 3 reactors. The accident released radioactive material, forcing the evacuation of over 150,000 people. It shook the world's confidence in nuclear power. Japan now faces the challenge of decommissioning the plant and managing the massive amount of contaminated water. To address the contaminated water, the Japanese government and the plant's operator, Tokyo Electric Power Company, or TEPCO, developed a multi-stage treatment process known as the Advanced Liquid Processing System, or ALPS. This system removes most radioactive contaminants from the water. It uses a combination of chemical precipitation, filtration, and ion exchange. ALPS is effective in removing most radioactive isotopes including cesium, strontium, and plutonium. These elements pose significant health risks. However, ALPS cannot remove one particular radioactive isotope, tritium. Tritium is a naturally occurring radioactive form of hydrogen. It is less radioactive than other isotopes removed by ALPS. It is also present in much smaller quantities, yet its presence has become a focal point of concern and controversy. The inability to completely decontaminate the water has fueled anxieties about its potential impact on the environment and human health. Japan's plan to release the treated water into the Pacific Ocean has been met with mixed reactions. Some countries, including the United States and Australia, have expressed support for Japan's approach. They cite the scientific evidence suggesting that the low levels of tritium pose minimal risk. However, many other nations, particularly those in the Asia-Pacific region, have voiced strong opposition. Their concerns stem from the potential long-term environmental consequences of releasing radioactive material into the ocean. Environmental groups have also raised alarms. They argue that the release could have unforeseen impacts on marine ecosystems. They also criticize the lack of transparency in the decision-making process. They call for more comprehensive environmental impact assessments. These groups emphasize the need to prioritize the precautionary principle. This principle suggests erring on the side of caution when dealing with potential environmental hazards. The scientific community is divided on the potential risks of releasing the treated water. Some scientists argue that the levels of tritium are low enough to be considered safe. They point out that tritium is already naturally present in seawater. They also note that nuclear power plants around the world routinely release water containing small amounts of tritium. These scientists maintain that the diluted tritium in the vast Pacific Ocean will pose a negligible risk to marine life or human health. However, other scientists express caution. They acknowledge that the levels of tritium may be low, but they emphasize the lack of long-term studies on the cumulative effects of low-dose radiation exposure on marine ecosystems. They also point out the potential for bioaccumulation. This is the process by which radioactive substances can concentrate in organisms higher up the food chain. This could pose risks to humans who consume seafood from the affected areas. Section 5. Troubled waters, China and South Korea. Voice their opposition. The Fukushima water release has become a point of geopolitical tension, particularly between Japan and its neighbors, China and South Korea. Both countries have expressed strong opposition to the plan. They cite concerns about the potential impact on their fishing industries and the health of their citizens. China has accused Japan of being irresponsible and opaque in its handling of the situation. South Korea, while initially more receptive to Japan's explanations, has also witnessed growing public anxiety and protests. The issue has strained diplomatic relations, with both sides accusing the other of spreading misinformation and fear-mongering. The water release has become entangled in existing historical and political tensions in the region, making it a complex and sensitive issue. Section 6. Beyond Science: The Geopolitical Currents of a Nuclear Dilemma. The Fukushima water release highlights the complex interplay between science, politics, and public perception when it comes to nuclear energy. While scientific assessments provide valuable insights into the potential risks and benefits, public opinion and political considerations often play a significant role in shaping policy decisions. The Fukushima disaster has eroded public trust in nuclear power globally. This makes it difficult to have open and objective discussions about the management of nuclear waste. The international community faces the challenge of balancing the need for pragmatic solutions with the imperative of environmental protection. Finding a way forward requires building trust, ensuring transparency, and engaging in open dialogue based on scientific evidence and mutual respect. The Fukushima water release underscores the need for greater international cooperation in addressing the legacy of nuclear accidents and managing the risks associated with nuclear energy. Section 7. A question of trust, transparency, and the burden of proof. The handling of the Fukushima water release has also raised crucial questions about transparency and the burden of proof in environmental decision-making. Critics argue that the Japanese government and TEPCO have not been fully transparent in sharing information about the treated water's contents and the potential risks. This lack of transparency, they contend, has fueled mistrust and suspicion, making it difficult to have a rational and informed debate about the issue. The burden of proof, in this case, rests on those proposing the release of the treated water. They need to demonstrate with compelling scientific evidence that the release will not cause significant harm to the environment or human health. This requires conducting comprehensive environmental impact assessments involving independent experts in the review process and being open to alternative solutions. Building trust and ensuring public acceptance hinges on demonstrating a commitment to transparency, accountability, and the highest standards of scientific rigor. Section 8. The Pacific's Plight, a Shared Ocean, a Divided Responsibility. The Fukushima water release is a stark reminder that the world's oceans are interconnected. What happens in one part of the ocean can have far-reaching consequences for marine ecosystems and coastal communities thousands of miles away. The Pacific Ocean in particular faces numerous threats, from pollution and climate change to overfishing and habitat destruction. The release of treated radioactive water adds another layer of complexity to these existing challenges. The international community has a shared responsibility to protect the health of the oceans. This requires strengthening international cooperation, developing binding agreements to prevent pollution from land-based sources and human activities, and investing in research and monitoring to better understand and address the cumulative impacts of human activities on marine ecosystems. The Fukushima water release underscores the need for a more holistic and precautionary approach to ocean governance, one that recognizes the interconnectedness of the marine environment and the shared responsibility for its protection. Section 9. Beyond Fukushima, Lessons Learned and the Future of Nuclear Energy. The Fukushima disaster and its aftermath offer profound lessons for the future of nuclear energy. The accident highlighted the importance of robust safety measures, the need for comprehensive emergency response plans, and the critical role of transparent and effective communication with the public. It also underscored the long-term challenges associated with managing nuclear waste, a legacy that will endure for generations to come. As the world grapples with the urgent need to transition to cleaner and more sustainable energy sources, nuclear power remains a controversial option. While proponents point to its low carbon emissions and potential to provide baseload power, opponents highlight the risks of accidents, the challenges of waste disposal, and the potential for proliferation. The Fukushima disaster serves as a stark reminder of the potential consequences of nuclear accidents and the imperative of prioritizing safety and responsible management throughout the entire nuclear fuel cycle. Section 10. The Precautionary Principle Weighing Risk in an Uncertain World. The Fukushima water release also raises fundamental questions about how we assess and manage risk in an increasingly complex and uncertain world. The precautionary principle, which advocates erring on the side of caution when faced with potential harm, has gained prominence in environmental decision-making. It suggests that in situations where there is scientific uncertainty about the potential consequences of an action, it is prudent to err on the side of caution and avoid or minimize the risk. Applying the precautionary principle to the Fukushima water release would suggest exploring alternative solutions that minimize the potential for environmental harm, even if those solutions are more costly or complex. This could involve further treating the water to remove tritium, or finding alternative storage solutions. The precautionary principle emphasizes the importance of considering the long-term and potentially irreversible consequences of our actions, especially when dealing with complex systems like the ocean. Section 11. A Legacy of Uncertainty, the Enduring Questions of Fukushima. The Fukushima water release will continue to be a subject of debate and scrutiny. long-term environmental and health impacts remain uncertain. The disaster has left an indelible mark on Japan and the world. It serves as a stark reminder of nature's power and technological failures. The legacy of Fukushima is one of resilience and enduring questions.